So we did this one yesterday, and what I want to show you guys is this guy, right? Well, first I want to review this, and then we can talk about the other things. All right. Here it kind of gives us a general overview of when x is approaching infinity or negative infinity, what are you going to get? So for the top right here, we have when x is approaching positive infinity. If you have anything being raised to a power, and n is greater than 0, meaning it's not it's not negative, it's not going to make it into a fraction. Anything that's greater than 0, then it's going to approach infinity. All right, that's the answer. And that just makes sense. You put anything in there, anything that you raise, like you can raise this to any power, and it'll just continue to go to positive infinity. And the same, not the same, but when you look at this one, when x approaches positive infinity, and the exponent is negative, then we're not going to get that result where it approaches infinity. We're going to get the result that it approaches 0, because if you look at this denominator right here, if that denominator gets bigger, bigger, and bigger, the number gets closer and closer to 0. Talk about that bottom part. I want to talk about, or just take a look over here at Desmos. Okay, so here we have x to the 7th. Now, if we play with this right here, you guys know like what happens if it's an even exponent, like what it looks like. You guys know what happens if there's an odd exponent, what that looks like. Okay, one kind of has like this N shape. I call this an N shape, and one kind of has this U shape. All right, if it's even, it's going to go like that. If it's odd, it's going to do the opposite. But both of these, whether it's odd or whether it's even, here's an odd one. If you are approaching positive infinity, both the graphs go to infinity. So like if I'm going this way on the x-axis, both the graphs go infinitely up, no matter what. No matter if it's odd or even. Okay, if I'm going to the right, they're both going up. Okay, but what if you're approaching negative infinity? What if I'm going the opposite way?
Same.
Okay, if I'm going the opposite way, if I'm going this way, I'm approaching positive infinity still with the even, right? So with the even ones, there's always positive, no matter which direction that you're approaching. But for odds, then you have something different. So if I subtract this, put my odd one back here. It doesn't matter which odd one. If you look right here and it goes downward like this as you go to negative infinity. So in that situation, we have negative infinity. So we have a different scenario. Okay, but we're seeing other ugly, nasty things like 1 divided by 2. Now you guys know that as the square root function, and it looks like that. But what if we have like an improper fraction right there?
What? Well, then it's still gonna work because.
Okay, let's see. If I put a 2 right there, oh wait, isn't that just 1?
Yeah.
2 over 2 is x to the 1 is just a line.
Yeah,
Okay, but what if I put a 3 right there?
It's gonna be the same because it's greater than 0.
Is it so? When I'm approaching positive infinity, this is approaching infinity. Okay, so what if I put a 5 right there?
Same.
Okay, what if I put a 7 right there?
Wait, why can't it be negative?
Oh, yeah, we can throw a negative on here, but that's going to change our function.
No,
That's
Now-
gonna approach 0.
Why is it on the negative side?
Because.
Because it doesn't exist over there. Because it's because of the nature of a root.
Oh.
Okay, even if it's
Oh, we got the copy negative inside the root.
yeah. Okay, what if it was? What if this denominator right here was not 2? What if that was
Then
3?
it would work for both sides.
Oh, now it works for both sides, but still, approaching positive infinity, it still approaches infinity. But if you're curious to see what an exponent is doing to the function, just throw it into a graph to get an idea of it. So back to this. Now that's what these graphs are supposed to be right here for, to help you guys see what's going on as you're going to infinity. Here's an even one, an even exponent, an even degree. Here's an odd degree. And this right here is just explaining to you what's happening. If you're approaching negative infinity, if it's even, you're going to go to positive infinity. If it's odd, you go to negative infinity, which we just saw in the graphs.
Don't move the screen.
If you have a negative exponent right here, then this is going to still equal 0 as you approach negative infinity. And that example is given to you with the rational graph, as you can see. When I go to positive infinity will be going this way. This line right here is getting closer and closer to the y equals 0 line, and same goes for going to the left. The other thing I wanted to show you guys, the thing I thought I was going to show you at first, to do something like this, there's a shortcut. We did it yesterday by dividing the top and the bottom by x to the 5th, because that's the highest degree on the denominator. Another way to do it is by using this theorem. Okay. Now it's kind of like it's a mouthful when you first look at it, but let's look at some specific situations. Here's your specific situations. Okay, this says when n equals m. Now n and m are your degrees. So right here, what's the degree on the top?
4.
And what's the degree on the bottom?
4.
Oh, so when n equals m, the n is on top, the m is on the bottom. Okay, when they equal each other, you can just do this. You can take the leading coefficients and multiply it times the limit as x approaches, in this case it's 0. We got 0 by going 4 minus 4. You go n minus m. So in this case we just get,
X to the 0.
x to the 0 is 1. And so the limit as x approaches infinity of 1 is 1, so 1 times 3 over 7 is 3 over 7. Okay, that's kind of cool. And this next one is your favorite one. Okay, you should star this one. If n is less than m, if the degree on top is smaller than the degree on the bottom, check it out.
Oh, yeah.
If we have a 3 over 4, we have the 3 over 7 still, but now we have the limit as x approaches infinity of x raised to the negative 1. How do we get negative 1? We went 3 minus 4. We always do the n minus m, the top degree minus the bottom degree. We get, what is that? What is,
0.
that's 1 over x, right? And when x approaches infinity for 1 over x, what's it approaching? 0. So we're going to take 0 right here and multiply it to the 3 over 7 to get 0. That's why you love him. Because whenever you have a negative exponent, it's going to go on the bottom, and you're going to get 0. You don't get what I just said? Okay, check this out.
Okay.
Do you know how I got negative 1 right there? Or how you get negative 1? You take the top degree and the bottom degree and subtract them.
Is that
Take-
just a theorem?
Yeah, this is part of the theorem. You take the top degree and you subtract the bottom degree, we get negative 1. And so this is actually saying 3 over 7 times the limit of as x approaches infinity of 1 over x. Now if x is increasing infinitely, then we know that this whole number is going to get closer and closer and closer to 0, so the limit actually is 0. This whole thing equals 0. What is 0 times 3 over 7? It's 0. So that's why you love him. These next guys down here, these are a little different. Okay, both of these have n greater than m. The difference between the two is this one's odd and this one's even. Now, they wouldn't have to split this up. You wouldn't have to split this up if both of these are approaching positive infinity. Okay, but because if they're both approaching positive infinity, it doesn't matter if it's odd or even, because they would just both approach positive infinity, which is what we saw on the other slide. So here we have an example where x is approaching negative infinity. So we have 8 over 3. So we have 8 minus 3. What's 8 minus 3? 8 minus 3 is 5. 8 minus 3 is 5, so we have x to the 5th right there. There's our 3 over 7, our leading coefficients, just like the previous problems. And so now you just have to find the limit of that one. What is the limit as you go to negative infinity of x to the 5th?
Negative infinity.
Negative infinity. Negative infinity times 3 over 7, oh, it's still negative infinity. So we're just going to write negative infinity when you multiply those two. Here it's positive infinity because of the even exponent. So would we be able to use this for this guy right here that we did yesterday?
Let's try.
Let's try it. Okay, now yesterday we found his limit, but let's try it the new way. Okay, this is supposed to equal, according to the theorem, this is supposed to equal 20 over 3 times the limit as x approaches positive or negative infinity of x raised to the... Now we have to go 2 minus 3. Or I'm sorry, 2 minus 5.
Yeah.
2 minus 5, which gives us negative 3. So we'll go. I'll write it out. 2 minus 5, which is negative 3. What is that going to equal? Well, we have a negative exponent. So that means this is going to be 1 over
0.
x to the third. So this whole piece right here just equals 0. And what is 0 times 20 over 3? 0. And that's what we got yesterday.
That's so much easier.